today's problem, which is a single element in a sorted array. You're given a sorted array consisting of only integers where every element appears exactly twice, except for one element which appears exactly once. Return the single element that appears only once, and your solution must run in log of n time and O of 1 space. So here we're given this input, and then our output is 2 because 2 is the only item that is appearing once within this array that contains duplicates with 2 of each other numbers within the array. So one of the observations that we can notice from here is that the number that appears only once, the number to the left of it and the number to the right of it is going to be different. So that's a keen observation that you'd have to think about in this for this problem. So let's get started and see how we can solve this problem. So initially, let's start out by writing out the inputs and outputs, and then the constraints, and then diagram out the approach to solving this problem. So our input over here is going to be the nums that from the question, which is this, and our output is going to be just 2. And so for this, let's see what the constraints are. The constraints are the nums.length is from, okay, so the size of the array can go up to 10 to the 5, and each of these items can also be of value of 10 to the 5, between 0 and 10 to the 5. Okay, so those are our constraints for the problem, and let's bring that also into our code, and then the next step, let's diagram out the solution. So what we observe, the key observation that we got from this is that the number to the left and the number to the right of the given array is going to be different. Keep that in mind so that we can actually use that in this case. So what we want to do over here is that obviously we would have to solve this in log of n. So definitely this is going to be something that would use a binary search. And we are using binary search because it has to be in log of n, and also the given input is in a sorted fashion, so that works in our interest. And so we're going to set the left pointer to be index 0 and right pointer to be index len of my nums minus 1. So what we're going to do here is we're going to find the middle index, the item in the middle, and then what we're going to do is we're going to check if the number, we're going to check every time whether the middle element is the number that we're actually looking for, and the number that we're actually looking for, the left value to that number and then the right value to that number would be different from the number itself. So that's the condition that we're going to check. Now, before doing that, one of the things that we need to understand is that this checking process can happen here, or it can happen here, or it can happen here, so anywhere. So suppose if it were to happen at the very first index, we can't look at a number right before the first index. And if it were to happen at the end of the array, then we can't look to a number to the right of the last element. So we also have to take into consideration that as well. So those are the two items that we need to take consideration. And so when we are looking and we find that the length of the left subarray, if that is going to be an odd value, then we know that that is the position where the item would be found. And so here, if we look at the left side, we know that there's 1, 2, 3, 4 here. That is to the left of the middle element, and here to the right of this we also have 4, which is equal. But what we're actually trying to understand is to the left of the element that is the duplicate of that. If that is odd, which means this 3, if that is odd, and if the right of this is going to be 4, then we know that this is where we actually have to look for. So then at that point, we're going to move our mid pointer to that position and then look for whether the left value of that middle element, and then the right value of that middle element is going to be the are going to be different. If they are different, then we found our target, which we're looking for. So hopefully that made sense. If it did not, I would recommend you to watch this over again. But if we were to code this, the solution for this out, initially we would have to say left pointer is going to be at 0 and right pointer is going to be at len of nums minus 1. And then after that, we're going to start our while loop where we're going to say while left is less than or equal to right. Inside there, first we're going to calculate our middle element, which is going to be left plus right minus left divided by 2. So this is going to be our middle element. And now what we're going to do is once we capture the middle element, we're going to look at one value to the left of the middle element and one value to the right of the middle element. So if nums of m minus 1 is not equal to nums of m, and nums of m is not equal to nums of m plus 1. So this is the case that we were talking about. If they are not equal to each other, so the middle element is not equal to the element to the right, or if the middle element is not equal to the element to the left, then in that case we found the number that we're looking for. Now, as I mentioned before, then if we are doing m minus 1 and if it goes out of bounds, we should also take care of that. So in order to take care of that, we say if m minus 1 is less than 0, if that is the case, or nums of m minus 1 is not equal to m, if either of this is true, and if the number at m, if the nums of m is not equal to nums of m plus 1, or in this case, if m plus 1 is equal to len of nums. If either of these conditions are true, then that means we do know that that's the number that we're looking for, and then we would just return nums of m. So nums of m is the number that we're looking for. While looking for that number by looking to its left and looking to its right, we also need to make sure that if m minus 1, if it's less than 0, or if the m plus 1 is equal to the length of nums, we also need to make sure that those bounds are taken care of. So as long as those conditions are met, then we know that it's the right number that we need to return. Now, as I mentioned before, we need to calculate the length of the left subarray, as I mentioned before, which is this particular left subarray, and then we need to calculate the length of the right subarray. If they are odd, then we need to move the right pointer to where, so if the left side is odd, then we would move our right pointer to where mid was, which would be around here, and our new mid is going to be somewhere here. But if it's the other case, then we would move our left pointer to where mid was, actually mid plus 1. We're going to move our left pointer to where mid plus 1 is, and our new middle is going to be over here. Yeah. So those are the two conditions that we need to take care of, and then after that, so that's how we will scan through the different segments of the given array. So to move those right pointer and left pointer to the left side of the middle element or the right side of the middle element respectively, the way to do that is we need to get the left size of the array, which is going to be m minus 1, and if that left size, we also need to make sure that the left size is going to be, it's going to take care of the conditions that we mentioned before. And so if nums of m minus 1 is equal to nums of m, then only left is equals to m minus 1. Otherwise, the left is going to be just m. Now, if the left size is going to be odd, which means left size mod 2 is true, then right pointer is going to be equal to m minus 1. Else, the left pointer is going to be equal to m plus 1. Now, we don't need to return anything towards the end because we know that it's definitely going to have at least one item, which is the desired item that we're looking for. So, and then towards the end, we just have to run this program and see what the solution is. Okay, so yeah, I guess that's a walkthrough of this. So let's run this and see. Let's index out of range. Let's see what is wrong here. M minus 1 is less than 0, or nums of m minus 1 is not equal to nums of m, and nums of m. We need to make sure that we check the m plus 1 is equal to len of nums at the very beginning, because if either of these statements are, if the first statement is true, then it just doesn't care about the next one, because if one of them is true, then this entire statement is going to be true. Let's try to run this and see. There you go. So it runs efficiently, and thank you so much for watching, and please subscribe.